we are back to task 3, and task 3 is talking about transition table for a 2 given NFA. With the 2 given NFA, when you look at this diagram, you can notice that the Q0, which is 0, 1, is the starting state, and with the double 0 indicating around the Q2 is the accepting state. So looking at the table, it says Q0 is 0, 1. So Q0, Q0, when you look at the mapping from Q0, you can get to Q1 because the arrows are pointing. When it gets there, it returns, so you can get to Q1. So Q0, Q1. And then Q1, from Q1, you can get to Q2. So from Q1, you can get to Q2. So Q1 to Q2, so Q1, back to Q1 again. You can see them. Then Q2 is accepting state. It's still accepted. I hope you are getting it. Looking at the bottom diagram, you can get to understand that from Q0, from Q0, 1, it gets to Q1, and then from Q1, it accepts the 0, 1, return it back to as 1, back to Q2, so it becomes 0, 1. That's the accepting state. So when you look at the table, everything is drawn to perfection for you to get a clear understanding. We can also make more search on it to get a better idea. Look at the state of elimination and regulation. So NFA, to reach the accepting state Q2, the machine must at some point reach A1, the only way out of Q0, followed later by 0, the only way into Q2 from Q1. Before and after that, critical 1, 0, any mixture of zeros and ones is allowed. The self loop on Q0, Q1, and Q2, eliminating Q1, merge the two loop into a single form from Q0 to Q0. So you can see that everything is explained to for you to get a clear understanding. See, the function is given in the string, so it has to accept 1 and 0. So Q0, and this is the empty set. You can see this is the function which was given in the NFA. So this is talking about, when you look at the D, it says 3 string accepting by NFA process with extended transition function. So this is also a question on its own. So recall NFA, this is the function Q0, 0 is equal to Q0. So this is the function given in the question, and the string 1 is such that 1, 0. So we use this function to solve the situation, to solve the problem. And when you look at it, you say that at any given point, the accepting state should be 1 and 0. So when you look at Q0, there is an empty loop here, which is equal to Q0, which is the function that tells you the function is 0 and 1. So you can see that Q0 is 0 and 1. So it's telling at any given point, you should have an empty set and then 1. So when you see Q0 and then 1, this is a symbol of, this is a Q. You think it's not, but it's a sign of an empty set. So this empty, which is the same as 0 and then 1. So at any given point, you should have 0 and 1. The same thing here, 0 and 1. The same thing here. This is Q0, this is empty. So you still have 0 and 1. So the function is telling you that at any given point, you should have 1 and 0. So that is what you are seeing here. That's the accepting state. So string 2. When we look at string 2, it says that 0, 1, 1, 0. So at any given point, you should have this accepting state. So Q0, 0, 0, and then Q0, which is 0. So it's telling the function 0, 0, 1. You can see this is empty, this is empty, and then 1. So that is the rules that we are following. And here too has been given a rule 1, 0, 1. So you have to follow that string as it said. Then from there you come and draw your diagram of the machine. So we'll do a next video for tax 4.